Hello everyone, let's get down to expressing this in partial fractions. The first step we must do is to ensure that the expression takes the format of a proper fraction. To do so, we must ensure that the highest power of x in the denominator is more than the highest power of x in the numerator. In this case, this is a proper fraction because it fulfills the condition that was mentioned. In the second step, factorize the denominator as much as possible, and we will then have x minus 1 squared. This is called a repeated linear factor, as we see a square over here. Thus, we can then split this term into its corresponding partial fractions, starting with a over x minus 1, and then always put a plus to connect the partial fractions together, followed by b over x minus 1 squared. Basically, these denominators are factors of the original denominators. In the next step, to make the working easier to manage, we are going to remove the fractions by multiplying both sides by x minus 1 squared. Now in doing so, we will then have x plus 1 equals to a x minus 1 plus b. Now the objective here is then to find the values of a and b. Therefore, in the next step, we will substitute convenient values of x. Now preferably, it should be a whole number so that we can help to eliminate the value of a or b. In this case, we substitute x equals to 1. A will then be eliminated as it is multiplied to a 0. And by solving this simple equation, b is 2. Another convenient number to use is perhaps x equals to 2. So replace all values of x with 2 and replace b with a 2 since we've found its value previously. Now solving the equation, a is equals to a 1. Now don't forget to answer to the question by expressing the term in its corresponding partial fractions. If you'd like to know more about how to convert other expressions to partial fractions, namely denominators with linear factors or denominators with quadratic factors that cannot be factorized, do check out the links in the description box below, and thank you so much for watching.